Hello interwebs, welcome to Let's Fix Computers. I've got an Acer Aspire 314 here, and it needs a new DC jack. It doesn't charge properly, and also it's really grubby. So we're going to replace that DC jack and then give this thing a good clean. Let's get into it. So we're going to start off by taking the back cover off of this thing, and we'll zap out the screws. I have had a look at this thing already. This has one of those awkward things where you're not sure if the charger jack is worn out, like on the charger itself, the plug, sorry, or whether it's the laptop. I needed to get a new charger for this laptop anyway, so thankfully I've got a brand new one on the floor next to me. And that was giving exactly the same problems. So it's not uncommon for chargers to just simply wear out, especially ones like this, where you've got the really thin connector. Like, look at this guy. I think it's a 3mm jack. And yeah, it's really slimline. You know, the tiny little spring on the inside there, those do wear out, and then they won't contact the center pin properly. But by the same token, I think what's really gotten this laptop is the outer springs that are supposed to contact the outer part of the jack have worn out. And I tried to bend them back into place, but that lasted for about 2 plug and unplug cycles, and then it just bent back again. Just metal fatigue. So, of course, this one has a soldered-in jack, because they always seem to be soldered in when they come in for repair now. I don't get the easy ones anymore. Most of the time, anyway. So, there is the back cover off. We've got an M.2 SSD in this one, which is quite nice. Not a lot of memory, but you could add more memory. And we've got our soldered DC jack up in the corner there. So, I'm going to keep digging into this and get the motherboard out, and then we can start looking to get that guy off the board. There we go. Right, so I'm going to hot air this off the board, but before I actually go in with the hot air, I'm going to reflow some fresh leaded solder onto these joins, just to lower the melt point a bit and make it a bit easier to work on. So, soldering iron is up to temperature, and let's just zap some more solder onto here. It can seem counterintuitive to add solder when you're trying to desolder something, but the unleaded solder that you get out the factory is very awkward to work with. It's all been designed to be hard wearing and stuff like that, but the moment you've applied some heat and fresh solder to a joint, it just immediately becomes easier to work on. So we're just going to put some new stuff there. And now I'll switch on the hot air station. I'm going to go maximum air, about 420 degrees or so. And I'll put this in the clamp now. Right, and now we're going to apply hot air to the back. And we're just going to heat up the back of the jack until it starts coming out. Shouldn't take too long. The anchors are the hard bit. There we go. Straight out. Easy. And now to clear those holes, I'm going to activate cheat mode and use my desoldering gun. Right. This might be a little bit awkward because these are quite long, these holes. We'll wet the join with some solder again. Get that down there and get it flowing. And then the desoldering gun go... And the hole is clear. Easy. Oh, this is going delightfully well. First try on all 3 holes. Perfect. I don't need to buy good quality wick. I have the Chinese soldering gun. Right, here's our new DC jack on the left. Nothing really of note, just those springs are not knackered on this one. Very well. That'll just drop straight in. So I've made sure that that's perfectly flat on the board before we start. And again, because we cleared those holes, comically easy to just press it into place now. Clearing holes is the most challenging part of replacing a soldered in DC jack. If you have a method for clearing the holes nailed down, then this is not a problem. All the times I've been doing this, like the very earliest videos on my YouTube channel where I was doing soldering work, like the early days where I had my big old, 1990 soldering iron and just didn't really know what to do. The problem there was just a complete inability to get clear holes afterwards, so you were trying to solder something in to holes that already had solder in and just, nightmarishly difficult. You'd never get an actually flat finish. Right, I'm going to put in just one anchor. And I'm going to check that I'm still flat. Which I am. And then we'll get the other one then. Just lingering for a moment just to make sure the solder flows into the hole. Still flat. Those anchors look good. Excellent. Let's go for the rest of them. And I'll just make sure I reflow all of those so we've got nice, good joins. And when you go around reflowing, just make sure to wait a moment between the pins, because if you reflow all of them at the same time, it might just shift in the board. And then suddenly you're not flat anymore and it's all gone horribly wrong, just at the moment when you thought you had victory. Perfect. Lovely. Alright, I'm kind of tempted to add a little bit more solder to that right-hand anchor there, but sometimes less is more. These are very big anchors. They're nice, long, flat ones, which is good for the you know, the directional force that they're actually going to encounter. So I've got all confidence in that. I'll just get the alcohol now, and we'll just scrub the flux and solder residue off of that. Now, some people noticed that I didn't add any flux there. That's because the solder I use, I don't know what this is, but it's ancient and it's full of flux. You can see all of the bubbles in it and stuff like that. This is my main spool of solder, and yeah, this spool of solder must be 30 years old, maybe more. Back from the good old days when they were full of all of the good stuff. And for jobs like this, you just don't need to add flux. If you're using modern solder, the modern stuff is designed to be eco-friendly, less toxic, etc., etc. That will probably appreciate you adding some decent flux to it. However, my stuff just doesn't need it. So if you're doing SMD reflow, that's a bit of a different matter. You should always add a little bit of flux there. However, just for through-hole stuff like this, it's fine. There we go. Like I bought one. You know, though, I'm going to add just a bit more solder onto that right-hand anchor. On the close inspection, like left-hand one, that's nice and coated on both sides. That one, the bottom looks fine, but the top, I don't know, it's just not quite everything I hoped and dreamed. There we go. When it comes to anchors, overkill is underrated. Okay, right, let's see how that jack is doing. Ooh, that felt a lot better than before I started. So we've got a charge light, so it works. Now let's do a quick bit of testing. So firstly, I'm going to disconnect the jack and see how quickly the light goes out. The light goes out straight away. Now the reason why this is interesting is now, if I plug that in, I can now just wobble this around, and I know that if there's the slightest interruption in power, the light will flicker. There are some laptops where when you disconnect the cable, the light will stay on for half a second before it goes out, and that can mask a bad connection at the DC jack. But with this one, because it goes out straight away, I know that if there's any bad connections there at all, it's going to just go out straight away. So that's a completely solid connection there. Before I started, when this thing came in, you had to put it at the right angle, and if you put it at the wrong angle, then it would go out and it would be charging, and you'd be like, okay, it's good, and then you lay the laptop down and then it's not charging. If you're interested in this, you know what it's like. Anyway, good. That's a success. Let's give this thing a good clean. I'll put the screws in first as a special treat. There we go. That is a lot better than it was. This greenish looking stuff here, that is like nail varnish or something like that. And I don't think I can get that off without leaving additional marks on the laptop. If I don't get paid extra to clean them. I clean them just because it's a nice thing to do. And If I was being paid to detail this, I would probably run the risk of getting a bit more vicious with that after talking about it with the customer. But this is just a quick once-over thing just to make it not gross. Dried on nail varnish, that's just visually unattractive, but it's not dirt and grime and horridness. So I'm okay with it. Anyway, past that, we're all done. I guess we'll turn it on just to prove that it works. Make sure it works, I guess. It's not working. Did I reconnect the keyboard? I have no memory of reconnecting the keyboard. This is the moment where electric screwdrivers are god tier. All of those screws that you've just put in and you realise you've got to take them back out again. And with the electric boys, you're just like, okay. Didn't connect the keyboard. Did I forget anyone else while I'm here? That's where probably a backlight would go, or a fingerprint reader or something like that. That's where the hard drive would connect if it had one. Everything else is populated. There we go. Moment of hesitation because the battery and the main battery and the CMOS battery both got disconnected, so it did some RAM training, and that's it. It's starting up. That's everything. Thank you very much for watching, everyone, and I'll see you next time. Bye for now.